Hi, we are Group E, and our team members are Arkar Ang, Manuel Yesid, Kay Sarmiento, Chris Philip, Pinal Patel, and Sanjay Ramesh. We are the global tech company, and our client, Click and Collect Co., is a large online shopping company which requests us to design and implement a security monitoring system based on Palo Alto and Splunk TM solution. This project aims to meet the requirements of the client for the following sections of the technical specifications. Number one, security information and event management solution, which is the SIEM, specifically Splunk Enterprise SIEM. A network security solution, PA firewall will be used to protect its network and resources. And lastly, for the cloud infrastructure, Amazon Web Services or AWS cloud environment will be used. This will help to improve the overall security and visibility of the organization's network infrastructure and data. The infrastructure we created is in Singapore region. We have one VPC in the infrastructure and we have one availability zone. So far, we have deployed the instances like firewall, Windows, and Splunk.
Okay, for this solution, we deploy one VPC. In this one VPC, we created 3 different subnets. The main subnet is the management, the second one is the private, and the third is the public management, public subnet. Regarding to the instances, we have created 8 instances. Mainly the AD directory, the Young host, the AIM Linux, the Splunk Enterprise, the Palo Alto interface, and the Windows client. So basically, all this solution is deployed in different instance types regarding to the CPU and the use of the resources. For instance, for the Splunk Enterprise, we use TD Median, and the Palo Alto instead we use the more advanced instance type, that is enforced large. So basically, each instance has attached 2 different subnets, management for one, public for another, and private for the Active Directory. So for instance, for Active Directory, we use subnetted, the attached private. And for this instance, we can see the solution that I deployed about Active Directory. We have deployed all the services about AD and DNS server. For AD, we have deployed the domain cccollect.core. That is our domain for this purpose. And also we have configured the DNS server, what we have created the forwarders, and we created also the direct and inverse zone. So if you can notice here, we have created the main users in order to get integration with Palo Alto, such as this kind of users allow to a communication between Palo Alto and IT Directory. Also, we have deployed a service account with LDAP that allow to integrate these kind of things. If you notice here, that's all the solution that it deploys so far, and that is everything what I deployed so now. One of the main components of this is the tracking and the logging about the instances, and that is basically what my partner I will explain you later. So, you can continue.
Sure. Thanks, Manuel. So let me share the screen here. Okay, as Manuel explained, we have been deployed the instances on the AWS infra. Before we start, let me explain the traffic flow. So in this diagram, we have a client machine, Windows client machine, and the gateway pointed to the firewall to go out to the internet. The idea is the firewall managed to detect the malicious traffic and send all the threat event and traffic log to the Splunk enterprise. then the security analyst log into the Splunk Enterprise and see the alert, see the log sent from the Palo Alto, the alert from there, and the dashboard to see the overview of the current security posture. So to demonstrate this, first we log into the firewall first, and also we log into the Windows client machine. To log into the firewall, actually we as manual display we integrated the firewall and ADA directory for the LDAP authentication. So we use the domain user to log into the firewall. To demonstrate this, we're gonna log out the existing user and log in using the ADA directory user. So firewall admin has fully access to the firewall. So to verify this, you log into the go to the dashboard and see firewall admin has been using the LDAP profile. So it's the one way to verify the user successfully authenticated using the AD user account. Okay, so that's a and in the firewall, we have been configured the policy and attach this policy with the intrusion prevention profile, which is antivirus, anti-spyware, and some Palo Alto provide a threat feature here. So if any traffic going through this firewall, they will expect with the Palo Alto threat prevention using the signature that download that from the Palo Alto update server. To simulate this, we're gonna need to log into the client server. So which is ready. I already log into the client machine here. So to simulate this traffic, we go to the Weka website, which is malicious payloads just for the testing purpose there. So just make it firewall to trigger the virus alert. And additionally, we also can make it trigger the anti-spyware alert as well. So to verify this, go to the dynamic update and just open the release note and search for the spyware. So these are the malicious C2 server. Just copy one of the domain name, go back here. So you can do the NS lookup here and also from the browser. Okay, then we verify is there any alert trigger in the firewall. So to check this, go to the monitor and thread. Okay, you will see there's a suspicious DNS query that we just initiated. And also you can see the virus echo file, which is the one weak echo file. So to verify this, you click on the echo test file here. So all these alert triggered by the Palo Alto should send it to the Splunk server. So this is the dashboard for the Splunk server. And click here, is there any trigger alert? So trigger alert here and slap all app and alert for the threat for the PA. So you will see here, there's an alert here. If you want to see the details, just click on the view result. It will show. it will show the details or the alert here. In the Splunk, there is a 3 modes here: fast mode, smart mode, and verbose mode. If we click on the smart mode, we will see more information about the alert. So if we check here, the alert came from the Palo Alto. This is the index that we created specifically for the Palo Alto. Then the next step is go to the Palo Alto dashboard. Go to the Palo Alto dashboard. Like say, if you click on the malware and last system minute, there's certain number of the malware called is the 28. All those are infected hosts. So 92 is a client IP, 1x is a window AD, and 49 is one of the machine in the infra. So this is called even in hourly interval. So the first event is in the March 17 and the last event on the March 19. So the third category with the timestamp. So and action taken by the vendor. So if you want to see the details of all these alert here, so with the today timestamp, there's an eCop file detected. So it comes from the Windows server destination to the malicious domain, malicious IP, and action and all those details information you can find it here. If you know about the search query, the command to search, you just type here and search all the useful information from the Splunk interface. So this is about how we're gonna use Splunk for the Palo Alto alert. Okay, and another use case for the Palo Alto is that we can monitor the configuration changes from the Splunk enterprise. So to check this, you go to the Palo Alto network application on which install on the Splunk, and go to the operation and click on the firewall configuration. So right now there's no result yet, so you have to filter out based on the time frame. So probably we're gonna do the last 7 days ago. See what kind of the changes happen on last 7 days. Okay, here we can see. So this is the latest event happened on actually today. So and there's a timestamp change showing all the configuration changes over time. Since we select 7 days, so it will show for the 7 days here, and you can verify the result whether success or failure. Another demonstration on this presentation is that how the Splunk can able to detect the network scanning to the search and reporting that's provided from the Splunk. And this is search query here. If you want to see the history here, you will see all the search history here. But here in our case, we're going to show the query that we crafted for this demonstration. Usually the scanning is a way for the attacker to discover the available services in the network. So normally this activity has to be initiated by the authorized machine. Alright, so now we can see those IP address we send it that this one can see more than 100 IP address and destination port 6. So if you want to investigate more about what kind of the traffic are they initiating, what are the destination IP, so just click on the event and click on view event. Then you will see the details of the event. We also have a Windows log onboarded here, and Windows log also sent into the Splunk server. So to check the Windows log, just click on the Windows event that we created the dashboard for the Windows event. Here we're gonna show only a few stuff just for the useful information. So in the dashboard we can even see all the Windows log error, warning, or the audit failure, and window events over time. And if you want to see about the user and the group info, so if you check the user and group, on that day, service account 001 firewall admin operator has been created, and all those configuration you have done or the added directory server, you can find it in the Splunk server. Yeah, all those dashboard we still building in progress, and we will show useful information in the final demonstration of this project. Yeah, thank you.